Okay, so still in section 5.2, this is on page 5 of the handout. We're going to talk about the population parameters, which are the mean, the variance, and the standard deviation for a binomial distribution. The mean is n times p. Remember, n is the number of trials, p is the probability of success. The variance is n times p times q. Q is the probability of failure. And the standard deviation is the square root of it. Okay, so we're going to do the same example that we did the long way on page 1, but now we know it's a binomial distribution. So a couple has 2 kids, so my number of trials is 2, n is 2. The chance of a boy or girl is equally likely, which means you have a half a chance of boy, half a chance of having a girl. And the random variable represents the number of boys. So my success in this case is one of the outcomes. In this case, is boy, which is when they ask for, and failure is a girl. The probability of having a boy, since they're equally likely, is a half. The probability of having a girl is 1/2 as well, or 0.5. So to find the mean, I'm going to take n times p, so 2 times 0.5, and I get 1. To find the variance, I'm going to take n times p times q, so 2n times p times q, which gives me 0.5. And then to find the standard deviation, I want to take the square root of that value. So just a reminder on the calculator, the square root, you're going to hit the second square root key and then go ahead and put those values in. If they don't have parentheses in there, you may have to put the whole thing in there. So I'll go ahead and put 2 times 0.5 times 0.5 in there. If your calculator does not have the parenthesis, you want to go ahead and put it in there. If you're going to do it this way, you can also just take the square root of 0.5. If you look at the example, this is the same answers we got from on the front page. It's just this was a binomial distribution, so instead of creating all the outcomes and creating the probability distribution, this is kind of a shortcut. Okay, let's go down this one down here from the homework here. This one is, I wrote down number 13. I hope that's correct. So very similar. You could pause this if you need to, but they're talking about 29 couples have children. The probability of a girl is 0.5. So a success in this case is a girl. Failure is a boy. Again, it just depends on whichever one they ask for. And it's 29. The first thing they ask for is the mean. So I take n times p, and I get 14.5. 29 times 0.5. The standard deviation, I take n times p times q. So 29 times 0.5. That's the probability of a girl times the probability of a boy is 0.5. And if you round that, you get 2.69258. Okay, then they want to do the range rule of thumb. The range rule of thumb is 2 standard deviations below, it's 2 standard deviations above. So they should be between these two. If they're outside them, it's unusual. Okay, so the mean minus 2 standard deviations is 14.5 minus 2 times the standard deviation, which is 9.1. And the mean plus 2 standard deviations is 19.9. So the range rule of thumb says basically most of the data should lie between these two. If they're outside those two, then it's unusual. So I'm going to pause this because it's kind of blurry, and let me fix that real quick. There we go. Okay, I already did it. Okay. So the question is a result of 23 girls significantly high? Will we expect our values to be between these two, the number of girls? So 23 is really high because it's beyond this range right here. So I'd say yes, it is significantly high because 23 girls is greater than 19.9. Again, between these two numbers, we expect the majority of the data. Anything above 19.9 or below 9.1 is significant. So this one is significant.